Use the diagram and information to complete the proof. Given that that segment AD is the perpendicular bisector of segment BC, prove that angle B is congruent to angle C. Okay, so I'm going to first scan to see if we have an example proof that uses the perpendicular bisector. So this one is pretty much the same setup because KM is perpendicular to LN, so that's our perpendicular portion. So KM is perpendicular to LN, and we had the LN right here. LM is congruent, is equal to the distance of MN right there. So we do have the same setup, and so this is just stating that it's a perpendicular bisector in a different way. So we have AD as our perpendicular bisector, so that means it hits it at a 90 degree, and these are the same distances. So let's go through, and this is proving for congruent angles, and this is proving for congruent angles. So we can use our this as an example. Just remembering that KL is similar to our AB and AC is similar to the KN. So I'm first just scanning until I see this. AB is equal to the distance of AC, and DB is equal to the distance of DC. So again, we had KL was similar to our AB and KN is similar to our KN. This one gives us the perpendicular bisector theorem. So that's our perpendicular bisector theorem, proving that the distances is the same as perpendicular bisector theorem. Then it goes on, and they're just joining this DB equals to DC all together. So that's okay. So segment AB is congruent to segment AC. Again, right here we have segment KL is congruent to segment KN, which is following very similarly from our steps. AB is congruent, the distance of AB is congruent, is equal to the distance of AC. So we have very similar steps right here, and this is definition of congruent segments. So it follows that this one is a definition of congruent segments. And then we have that KM is congruent to KM, and on ours we have that AD is congruent to AD. So very same setup, different letters. So this is the reflexive property of congruence, so that's what C is. Reflexive property of congruence. And then it states that triangle ABD is congruent to triangle ACD, and this one says our triangles are congruent to others with a question mark. You could quickly just click on this and click yes, I just guessed luckily, or you could go back through and say what was the information given. Well, they gave us that AB was congruent to AC, so we had AB was congruent to AC. There's our side. Stop pushing buttons. And then, sorry, I have kids joining me at my computer desk. So then we have that the distance of DB right here is congruent to the distance of DC. So there's our other side, and then we laid it out that AD was the same. So we did, in fact, have side, side, side. So that's another way you could prove it as to what we were using. So this is side, 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 congruence postulate. So now we're here. And then it states that our angle B is congruent to our angle C, very much similar to the angle N is congruent to angle L is congruent to angle N, and it's the corresponding parts of congruent triangles are congruent. So angle B is the corresponding part to angle C, so they are congruent since we stated that those triangles were congruent. So that's what I'm looking for. Corresponding parts of congruent triangles are congruent. And that's how I would step through this question.